to parameterize that surface. That's a disk. So it's a disk, and you can do two parameterization. I think one of them is given in your notes. One of them I'm going to do in here. In technicality, I like one parameterization better than the other parameterization. That's my personal preference. And most books do the other parameterization, which makes it confusing. This is the parameterization I like better. So what I like better is that here I saw for Z, oh, fine. Z equal to -6 plus 2x plus 6y. Then over there, because I know that x and y are within this circle, x and y are within that circle, I use x equal to r cosine t and y equal to r sine t, and then z equal to, plug those in. But that's a parameterization I do. That gives me t is between 0 and 2 pi. R is between 0 and 1. So now G of R and T is going to be R cosine T, R sine T minus 6 plus 2R cosine T plus 6R sine T. G sub R is going to be equal to cosine T, sine T, cosine T, 6 cosine T, no, 2 cosine T, plus 6 sine T. This is not working as well as I want to, because T sub T is going to be negative R sine T, R cosine T, and then 2R minus 2R sine T plus 6R cosine T. And then cross of them is going to be, you're crossing these two minus those. Is this 0? No. No, it's not 0. This is going to be 12. Okay, there we go. 12. No, no. This minus this. You guys are getting to that point. I'm getting to that point. We're going to survive this. Cosine T. And then the J part of the cross product is it's going to be 2 sine T. Right? Right. No, I think I'm messing this up. Sorry, guys. I knew it's going to happen. I so knew it. Who cares what this is? You know what? Because curl doesn't have X or Y component. So it's something. And that one is something else. Why? Because curl just has Y component. I just need to find the Z component of this. And that is R cosine squared T plus R sine squared T. So it's going to be R. So it's something in R. That's all I needed to do. And the nice thing about this is it's actually looking up, because R is the positive, right? So it's looking up, so it's the same direction as what we wanted. And now I have to, so N is something and something else and R. Now I do curl of F, parameterize, add what I need, which is going to give me parameterization is Y is that. So I get 0, 0, and -2R sine theta, sine T. And I dot these two together. The orientation, again, orientation matches. And then dot these together, curl of F dot N, the something something goes away. So I'm free of something something. I get this. Then I do the surface minus 2R squared sine of T. R runs from 0 to, what was the R? R was 0 to 1, right? R was 0 to 1, T 0 to 2 pi. And then I compute, and this turns out to be 0. So the surface integral of the curl was 0. Therefore, the circulation is 0. Sounds good? So that's something that you sort of, so let's repeat after me. Green's theorem says circulation in 2D over a closed, over a boundary, circulation in 2D over the boundary is connected to the circulation on the surface, right? So let me write it down. I'm summarizing it because I didn't do Green's theorem or Stokes theorem and divergence theorem here. So Green's theorem says the